Hi, everybody. It's great to be back. Okay, quickly, I'm going to give you a little, I actually want to talk a little bit about the process behind the work that we do in Arduino and some of the values that to me are important. And it's interesting that yesterday, in some of the talks I listened to and also during the venture capital sort of panel, there was some of this concept that popped up. So I call this talk People Over Megahertz. This idea that, sometimes taking care of the people is more important than the actual sort of power of the technology you're working with. And so about myself, when I was a little kid, I sort of got into electronics because there was some magazine. This is like an Italian magazine from the 70s, 80s. Obviously, there's got to be a kind of lady using a radio on the cover. And so this is the kind of magazine that the people used to kind of learn about electronics back then. And they were not exactly what you would define as user-friendly. And also the projects were not very exciting. So to look at the big title, that temporizzatore in Italian means a timer. So the leading article on this magazine was about a timer. So obviously it was also hard to kind of get people excited about it. Like everything was kind of difficult for me to understand as a kid, So I was trying to understand, but it was very much designed for people that were into the technology itself more than what you do with the technology. Then I got this as a present. It's a German kit that was made in the 60s by a company called Brown. And it was incredible because all these blocks contains parts and you can kind of connect them together magnetically and you build circuits. And then you get these little sort of manuals where you kind of follow the instructions and you build circuits. But the boxes are transparent, so you can look inside and you can see the components, you see the schematic diagram. And also it came with this book with beautiful illustrations where the electrons are these kind of red characters that jump around, and that's a transistor, and the pump is a power supply. And so really you were building functioning stuff very quickly. And the whole box was, in a way, an experience. You open it, you learn, you go through different experiments. So you see this says, hey, look, I just built a radio in 2 minutes. That was the original advertisement from the 60s or 70s when it came out. So what was interesting about that is that me learning like that, obviously I got an interest in electronics, but I also got an interest in design out of that experience early on, because this kit was actually designed by Dieter Rams, who is one of the most important designers of the world, and he was working at Brown in the 60s and 70s. He made a lot of iconic projects that actually inspired a bunch of kind of Californian designed devices that you can see here. So obviously his way of looking at design influenced a lot of designer afterwards. And he actually kind of came up with this list of different things about design, how design has to be innovative, but it also has to be honest and long-lasting and makes a product understandable. So there's a lot of things about design that are important because it's concerned with people and the way people interact with things, with the space. And I think this is very important when you design something even which is about technology, that you have to be caring about the people who use it more than the technology you just put in. And so when I got first computer, it was like the early 80s, and these are the pictures that you see in the guy in the kitchen doing graphs. That's a very exciting way to, use. But the first computer I used was like this. And you had to, you punched hexadecimal numbers on a keyboard, and then you get hexadecimal numbers on the LED display. That's not exactly what I would define as satisfying user experience. But it was, So I realized that this wasn't, there must be better ways to kind of, do computing and not have to kind of look at numbers all the time. And also actually, again, the world of design looked at the way people interact with the computer early on. This is a picture from a computer from the late 50s called Elea 9000. And this Italian designer actually started to look how to design the control panel. And also, their issue was that the computer was made in Italy, but most of the computing stuff was in English, so they started to come up with symbols to replace words, because they wanted this to be universal. They didn't want to have to translate the whole thing all the time. So the first computer that I used that actually gave me some pleasure in sort of computing, although the keyboard is a bit of a nightmare, is this ZX81 that was also sold in the US. And the interesting thing about this device is that you press the buttons and kind of words, in single basic commands come out when you press one single button. And actually, it's very hard to make syntax mistakes with this, because in a way, once you press a button, the next button, it relates to what you just typed before. So it was kind of guiding you through the construction of the basic code. And although it only had like 1 kilobyte of RAM, I could do a lot of stuff. When I used too much RAM, the screen started to shrink. So you can start to losing lines of screen at the bottom because there was only 1K of RAM. But I made a lot of stuff. And then obviously, one of the things I was known for when I was a kid, that I would take everything apart. That's how I learned, by taking stuff apart and look at what other people do. So when I looked at the circuit also had this kind of feeling of simplicity. There's only like few parts. You can even buy this as a kit and assemble it yourself if you really wanted to. But again, this thing also came with a book that I would say is a pretty good book. Even now, if you read it, you can learn about basic programming, and it provides you with like an experience that kind of moves progressively into more complex concepts. And again, the box was an experience. You get the computer, you get the manuals guiding you through. I understood the whole idea of creating a whole product. So fast forward to 2002. Otherwise, it's going to take a few hours. And, so I was teaching in this design school in the northwest of Italy, in Ivrea, where a lot of the Arduino boards are still made. And this is the place where the Olivetti company was born. And when Olivetti sort of went down the drain, they decided to make a design school that was concerned with interaction design. So a specific kind of branch of design that looks at the way people interact mostly with technology. And the idea that you can design the shape of something, but you can also design now the way people interact with that object. And that interaction is very, very important. You can have a beautiful product with a terrible interface, and it's not nice, it's not beautiful, it's not a pleasurable experience to use that device. So the students in this kind of schools, they don't have a background in technology. They don't know how to program, they don't know how to do electronics, and we have to teach them so they can make things like this. This is a project that we made in Ivrea. It's a wallpaper that you can use as a display. So this is a 4 by 2 meter display made of paper that changes color. So this was one of the very, very early things we made with the Arduino technology before it was even called Arduino. So you have 2 weeks, 2 to 4 weeks to teach people about electronics, microcontrollers, and everything, and you have to compress it so the students do that full time, and sometimes they got a bit tired. So this is about 2004, like 2 o'clock in the morning, people trying to kind of take a rest before finishing their project. But they do it. They come out at the end of these 2 to 4 weeks classes, and they know how to make stuff. And so I think it's looking at the way we work with students taught me a lot, and obviously Arduino came out of that work. But also there was some interesting work done by people like Eric von Ippel that I came into contact. I started reading this book, how innovation is happening more and more from the bottom up, that customers are telling companies, this is what you should do with your product. And in the book, it talks about a toolkit for user innovation, has a number of parameters, a number of key points that I think resonated with what we were trying to do with Arduino, this idea that it's a user-friendly, learn by trial and error type thing that teaches people. And when I was teaching in this school, the tools that you would find on the market, they were mostly things like this, which are designed mostly for engineers, which like a lot of options, a lot of jumpers, a lot of connectors, But some of my students, they look at this and it looks too complex. There's way too many options. And the way the circuit looks, I think influences psychologically the student, and when something feels too complicated, they feel they can't touch it, they can't figure it out, This is how you program. The processor on the Arduino Due is programmed with this kit. If you buy this kit from Atmel, and for my students, this kind of setup is out of the question. It's just way too complicated. So in Ivrea, we did quite a lot of work figuring out different tools. So these are a picture of all the tools we developed through the years in Ivrea. So we made this board which came before Arduino, where we tried to make it simple so that you can build it yourself. This idea that you can build it yourself gives a strong sense of ownership. So this group of people, and it is the one that kind of came together then to make Arduino, and so that collectively also we had the idea that you can share the hardware, you can share the design of the board so that people can build upon it. But in a way, if you look at it, Arduino is actually a mashup of open technologies. So there's a bunch of different technologies that we put together, and we wrapped it up in an experience. And I think that's important for us, the user experience, the out-of-the-box experience, the speed. How long does it take for you to go from zero to something that's working? That time, it's very important. The longer it is, the more people you lose in the process. And also, we look at ways how you can deal with open source and so we opened up everything and we tried to protect the brand. Take an example, for example, from the fashion industry. So this is a TED Talk that I recommend you watch. It looks at how the fashion industry doesn't have all the protection that maybe the movie industry has, and it makes much more money, and still they can't trademark this shirt because it's all about the branding and the relationship with the brand. So in a way, we started to try to apply design to bare circuits. In a way, circuits are normally designed to be in a box, plastic box. You don't see them. So obviously, in a way, when you start to sort of use products that have no enclosure, the product itself has to convey some message about the simplicity. So the idea about Arduino, especially this model, is that it's incredibly simple. There's very, very few parts. So when you look at it psychologically, you feel you can potentially grasp the device, the number of components. In your brain, I'm sure your brain starts to make a factorial, multiplying all the numbers of components on the board, and decides how hard this technology could be. And we also try to apply some of the learnings in some of the work we did. Like this is the book that you're going to get, I didn't know, where we decided to use hand-drawn illustrations to kind of, borrow a little bit from the hand-drawn illustration that Dieter Rams put in the book to make it less scary for people. The idea of the hand-drawn illustration is less scary in a way. And we got some interesting comments. Like at the beginning of the book, there's about 18 pages where I explain the spirit of Arduino. In a way, some of the ideas, this was made before the maker movement was kind of big. So some of the ideas are a bit sort of naive now, probably. But in a way, it's, there was the idea that there's a whole set of ideas behind this piece of electronics. And I got this interesting comment from a guy saying, I found the first 18 pages to be fluff, but I'm sure it appeals to a younger generation. So in a way, it's interesting how some of the things you do to make the product more inclusive, to go after the people that don't know about microcontrollers. They don't even want to know what a microcontroller is. They just want to make stuff. That stuff, in a way, still is hard to convey, this is what we're trying to do. And also, the software, the IDE is obviously not as powerful as any of the more advanced tools right now, but it's designed to be incredibly simple, to have very, very limited minimal interface, and to make the whole process very quick. So the out-of-the-box experience. And I got some interesting comments as well. This is famous. Arduino, the baby talk programming for potheads. And some nastier comments from Hackaday, like, the Arduino is the main selling point for all those women, artists and painters. Yes, I know, yikes. And so in a way, when you're trying to do something to simplify technology, there is this idea that if you're doing it for kids, it's fine. If you're trying to do it for adults, no. You're ruining their minds or not teaching them the right stuff. So in a way, we try to apply design to all the elements to have a distinctive, in a way, look, and so the people connect to the product more directly. And also the way we try to lay out the parts on the circuits, the way we got these orange connectors made so that you can kind of figure out the different functions. So we try to build, in a way, a brand around Arduino so that you can recognize it, and it's easier maybe to detect when an Arduino is probably not exactly what it claims to be. But again, I like this idea of the out-of-the-box experience, the idea that you open the box and you're like, wow, you open it and it's kind of nice, and also, even the tape we put around the boxes is custom, and it says, we love open source. You get the big box full of Arduinos, and it sends the message. And then you find, it helps, because when you look at this, it's clearly a fake that you find on eBay. And look at the fact they wrote the official version. I don't understand what they meant. Maybe they meant the official clone of Arduino. But in a way, it's easy to detect that even if they're copying the brand, it's not the exact same. They even write made in Italy. But I can tell you that Sicily is in the wrong position, and Sardinia in that picture is kind of pointing at Tuscany in an alarming way. It's like, it's like a missile. So they copy, but they don't know exactly what they're copying. So looking at the other stuff we're doing around user experience, we worked on this starter kit recently, where the original starter kit was like this. It was really, really, really bad. But the idea is that I prefer to have zero design than instead of doing it not properly. So it took us a long time, but we made something that I think when you open it, it really gives you, some kind of an experience in a way. And again, this is a box with a book that you can see here, some pictures. It contains 15 experiments. You go through it. So you open that, and it's not a product. It's an experience. You go from zero to all the, you go to the end of the Arduino experience in a matter of a few days. But I think it was important to have this thing that you open it, and it's got layers that you kind of pull out. And again, it's about the experience. We also worked on this project called the Explorer, which is kind of like a game controller type thing based on Arduino with a bunch of sensors. And again, this is designed to be a device that you take and you can use immediately. You plug it in, and it's already programmed to be a game controller for Super Tuxkart, the open source game. So you can plug it in and use it immediately, and then you can learn how to program it. And you got all these sensors on it. And in Maker Faire, in a couple of days, we're launching this thing, the Arduino robot, that again, we're building it as an experience, something that, you can program. It has an interface. It has all these different layers to the experience. And once you use it, you can build upon it. You can take it apart. You can interface it. So again, we're trying to build more and more experiences for people to go through. And yeah, so I wanted to quickly go to show you a couple of the things where I think we're interested in looking at right now, where the experience is taking the maker movement. So there are these tools like Fritzing, for example, where you have the whole kind of electronics experience in one tool, where you can do the schematic, you can do the PCB, you press a button, the PCB goes to Berlin, they make it, they send it back to you. So I think these kind of inclusive tools that have all these features are going to be very important in the future. There are going to be more and more tools with all these features combined. You do electronics and software in the same package. And more about modular electronics. This is something I've been working on for a few years now. I started in 2006. And this idea of the modularity of electronics, some people have called this object-oriented electronics. And I like this idea that you have modules that become more and more intelligent. But again, we applied some design rules to make it more like a system. You can find this also in the little bits, for example, and in some of the stuff you saw yesterday. So I think, we are on the edge of a kind of new step in the maker movement. And I think that, a lot of the people in the audience maybe are working on the next big thing, and somebody's working on the Arduino killer. And, please continue. And But please keep in mind the experience. You know, you can put a processor that has 100 megahertz less than another one, but the user experience makes a huge difference to people. So, you know, less megahertz and more attention to people. Thank you.